Hey guys, welcome back to Lehigh. So last we left you, we talked about inputting numbers or expressions into functions, evaluating. We talked about finding the domain and range and what makes a function a function. That was passing the vertical line test. I'll have a link to that video in the description box below. So in this case, we need to talk about transformations. So here we've got some function f of x, okay, which was actually in the first example of this little booklet. Again, the review questions there will be a link to the review questions in the video in the description box. And in this case, we need to identify these transformations, okay? So here's what I'm going to do. I'm going to generalize this a bit. So f of ax, okay, that's trying to restate that, but in a general way. Okay, so this is a general function, f of ax. Now, if the absolute value of a is greater than 1, this will count as a horizontal, horizontal compression. All right. On the other hand, if a is between 1 and 0, or the magnitude of a, I should say, then it counts as a horizontal stretch. All right? So what that translates to is if we've got y values and x values, in this case, actually x values. If we've got x values on our current function f of x, this is f of x, right? This thing is f of x. We need to take all the x values and cut them in half. So for example, we've got negative 4. So the new x value for this function a is going to be, for example, negative 2. Now keep in mind I haven't accounted for anything else, right? Any other transformation yet. But it seems like nothing else is affecting the x coordinate, just the 2. So yes, this x coordinate would be negative 2 instead. This one would be negative 1 instead. This one would remain 0, because half of 0 is 0. This one would be 1, and this one would be 2. So it's going to be compressed horizontally by half. Okay, now what this negative does is it reflects. We call it a reflection. So the y values will literally be opposite, right? They will instead of having a y value of 2 at this x value, it will be reversed to negative 2. Again, keep in mind I'm not including the horizontal compression just yet. I'm just talking about reflections alone, right? So a reflection about the x-axis, which this represents, would make the y value instead of 4 would make it negative 4. Minus 3 means a vertical shift down by 3. So why don't we try this? Let's see. So the new x-coordinate will be negative 2, right? So far, this point is represented by this guy. However, I haven't accounted for the reflection, so let me account for the reflection. Okay, so that's that guy, and now I go down 3. Notice I didn't do the shift before I did anything else, right? So 1, 2, 3, and that is my new point. Okay. All right, let me erase that now. Okay, let's do it for the other guys. So cut it in half, so negative 1. Okay, but now it's going to be at negative 4, and then 1, 2, 3. All right. Great. So far I will connect. This will look really bad. So far so good. Next, this is going to stay at 0. It's going to be reflected about the x-axis, so it's going to be negative 4, and then down 1, 2, 3. Okay. So I'm going to connect it. All right. Here, I'm going to have it at x equal 1. And instead of being at negative 2, it's going to be at positive 2. And then I go down 3 points, right? So let me try this again. So I guess I'm kind of losing myself here. So it's going to be at 1, right? It's going to be at positive 2 instead of negative 2 because it's reflected about the x. And then 1, 2, 3. So it's going to be here. And now I connect. This is going to be really bad. I'm sorry. Okay. Not too bad. Could be better. Next, the x value is going to be at 2. Okay. The y value is it's at the x-axis, so the y value is 0, so reflection won't do anything. But the shift downward will do something. So 1, 2, 3. And I've got my new function, and this is negative f of 2x minus 3. Okay, so that was one example. All right, now we're going to do the rest. Or at least we're going to do B. Let's just try B. Okay, now notice I had a 2 out here, right? Or sorry, inside the actual function, so it was beside x. This time the 2's out here. The easy way to remember this is when there's a 2 outside, and I have, so a 2 follows this condition, right? But instead of being a horizontal compression, it's going to be a vertical something, and it's the opposite to the horizontal transformation. So instead, this means a vertical stretch by a factor of 2. Vertical stretch by 2. Okay, so the opposite, all right? Complete opposite to what you think. So let's see. And here, right, we've got no shifts on the outside, so nothing affecting the y. This is going to be a shift. Now it says minus, so in your head you might think shift to the left by 4. It's actually a shift to the right by 4. Those are the only 2 transformations done. So all I have to do is literally double the y values and go to the right 4, and that's my new point. That's it. So this y value, instead of being 2, right, it's going to be at 4, and then 1, 2, 3, 4. This is my new point. Okay? So that's this point being transformed. Then this y value is at 4, right now, but it's going to be at 8, and then 1, 2, 3, 4. Okay? So that's going to be my new point, and I'm going to go up like that, right? So I'm going to go, because that's what's happening here, right? Now, again, the y value is at 8, right? But I'm going to go 1, 2, 3, 4. So I'm going to connect this across, and this guy's going to be at negative 4, but it's instead of negative 2, it's going to be at negative 4. It's going to be doubled, and then 1, 2, 3, 4, right? And this is where it gets kind of nasty. All right, let's see if I can do this. I wish I had a ruler. That is so bad. I'm sorry. Okay. Bear with me. All right. Now, the y value right now is on the x-axis as before, and so the vertical stretch by a factor of 2, doubling 0 still gives me 0. So all I have to do is just translate to the right by 4. 2, 3, 4. Okay, and I connect, and that's my function. And so this guy, okay, is 2f of x minus 4. That easy, right? Now the next one looks kind of crappy, all right, but we'll get through it. Okay. All right. So now, remember this meant vertical stretch by a factor of 2. So this means vertical compression by a half, right? So the y values will be halved, okay? So we're going to have to do this in steps. So the y values will be halved. So instead of 2, it's going to be 1. Okay, so let me do this. Ugh, terrible. It's going to be a 1. And this means a horizontal stretch by 2, right? So instead of having it at -4, it's going to be at -8. Okay, so that's my new point. Now this means a horizontal, sorry, the negative means a horizontal, a reflection about the y-axis. So I would say a horizontal reflection, but anyways. So instead of being at -8, it's going to be at +8. All right. And then alas, that -6 means bring it down 6 points. 1, 2, 3, 4, 5, 6. So that's the first point, right? Look at how crazy this is. Okay, next, this guy starts at 4, so the new value is going to be at 2, okay? And then it's going to be a horizontal stretch by a factor of 2, so the new point's going to be here, okay? And then the negative means that the x values are reversed. Okay. And then going down 6, 1, 2, 3, 4, 5, 6. All right, so that's my last point. That's it. That's the second point, sorry. So I connect them. Boom. Next, this guy is halved in the vertical, so it's going to be at 2. Now this this half does nothing because the x value is at 0, right? It's the y-axis, and that negative will do nothing. So I literally just go down 6 points. 1, 2, 3, 4, 5, 6. Okay, so I just connect. That's supposed to be a perfectly horizontal line. I apologize. All right. 2 more points. So now this guy's going to be halved. So instead of being -2, it's going to be -1, right? So it's right there. And the x value is currently 2, right? So now it's going to be doubled to 4. And then it's going to be reversed to -4. Okay. It's going to go down 6 points. 1, 2, 3, 4, 5, 6. All right. So that's erased, that's erased, that's erased. So I connect. And one last point. So you're still with me? If I make a mistake, just let me know. Things happen. So the y value is 0 right now. It's on the x-axis. The half does nothing to that, right? However, the x value is 4. So it's supposed to be twice as big. So 8, right? But then it gets reversed to -8. Then it goes down 6 points. 1, 2, 3, 4, 5, 6. And so we get this guy. Okay? So it's kind of like a reflection about the y-axis, reflection about the x-axis, and a bunch of compressions and stretches. Okay. Last bit, it wanted the inverse function, right? So it wants f inverse. Easy way to do this. Very easy. Draw a line y equals x. Okay. You will probably do a better job than me. I'm using my tablet. Okay. Okay. Terrible at the end, but anyway, so all I have to do is use my y equals x line as a mirror. So I've got 2 boxes, 3 boxes, so I go 1, 2, 3, okay, and that represents that mirrored point. This guy, I go 1 box, 2 box, 3 box, okay, 1, 2, 3. Okay, and so I connect them. All right, and I get this guy, so I go 1 box down, 2 box down. Notice I'm going diagonally through the boxes. 1, 2, that's that new point. So I do this, I go vertically up, although that is not vertical. So I go vertically up. All right, and then so I've done these 3. Now I have to get this point. So I go 1, 2, 1, 2, right there. So I connect. All right, that's not bad. That's a pretty straight line. And then here, I got to go 1, 2. So 1, 2. So that's my new line. Okay, it's a little hard to see, but it is this sucker right here. Okay, probably should have done it in dashed lines, but it's this guy. Okay, so that's my inverse function. All right. So that is basic plotting of transformations and inverse functions. So do the same trick here, right? So it wants a quadratic. So it's x squared minus 2. It wants me to graph both f and f inverse, right? So let's see. This is basically x squared, but translated down 2 units, right? So it's going to start here. So let's do that. Oops. Pen isn't working. Oh. Oh, now it's working. Okay, we're good. Okay, let's come back. So here is the parabola. Okay. So this is the original function. 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. Okay, so this is the original parabola. That is really awful. That's okay. Okay, so, and then I'm going to draw my line, right? I'm going to draw my line and try to go diagonal. So this point 1, 2, that's my vertex. This is going to stay on the line. This guy's going to go 1 and then 1 here. So that's going to be my second point. So I can already see it's going like this. It's going to curve that way. That guy is on the actual y equals x. So that stays. And then the other guy, which is right there, is going to be 1, 2, 1, 2. It's going to be right here. So my actual inverse function, it's not really a function, but the inverse, f inverse, is right there. Okay? So this is the f inverse. And it's not a function because it does not pass the vertical line test. Remember that. Now, if you want to determine the equation for it, it's very simple, and I'm sure you've seen it. All you do is, if I call this y, replace x by y and resolve for y. That's it. So replace x by y and solve for y again. So we get, let's see, add 2 to both sides. Okay. So the 2's cancel each other. So y squared equals x plus 2. That means that y equals, and be careful, you got to include both plus or minus x plus 2. Okay? Remember, this is not a function because if I plug in an x value, I will always get 2 y values, and that's not a function. It's always 1 x value, 1 y value. Okay? And so that's what I got. So thank you so much. And I guess I'll see you next time. Sorry about some of the glitches, and hopefully you were able to follow along. So have a good one, and we'll see you next time.